understanding, or our basic understanding and understanding of the characteristics of circular motion, and we're going to be applying it into real life problems. All right, so without further ado, let's get started. So let's get a problem up in here. Problem, we have a 0.55 kilogram mass ball. All right, 0.55 kilogram mass ball. And it is attached to the end of a horizontal cord. So it's attached to a horizontal cord. All right. And it is revolved in a circle. So if it's a horizontal cord, we can already make the assumption that it will be in a horizontal circular motion. So it is revolved in a circle. So it is revolved in a circle. And I'm sorry, that's circle with the radius of, they give us a radius of 1.3 meters on a frictionless horizontal surface. So this is frictionless. We're assuming that it is frictionless, which is pretty important because that would be an additional force acting on our ball. But since it's frictionless, we don't have to worry about it. And do they give us any more information? Well, if the cord will break, so the problem states the cord will break, so cord will break if the tension, so if our tension force exceeds 75 newtons. So the tension force has to exceed 75 newtons for this cord to break. And it asks us to calculate the maximum speed, the max speed that the ball can be moving in. All right. So this is the problem. And remember, rule number 1 of physics, always try to draw a diagram. So you can better picture and derive better, more meaningful equations for this specific problem. So we know that we're in, once again, horizontal circular motion, but now this problem is a little bit more different from the first 2 problems that we did because now it's implementing a cord or a string. So we have to take that into account. So let's say that we have a string, and let's say that its center is here or something, or one point of the string is here, and we draw out the remaining of the string, or we can draw it out like this. And at the end of the string, we have a 0.55 kilogram mass ball. And this ball is moving in horizontal circular motion. So let's try to draw that out to the best of our ability, or to the best of my ability. So it's in horizontal circular motion. All right, horizontal circular motion. Now that's my best attempt to a circle. And okay, so this is our diagram, or a decent drawing of a diagram. So let's try to put in some meaningful information from the problem. So the mass of this ball, they gave us, the mass of the ball is 0.55 kilograms. And they told us that this ball is revolving in a circle that has a radius of 1.3 meters. So we know that the length of this is 1.3 meters. It's frictionless, so we don't have to take into account that force, but of course we'll draw a force diagram additional to this. And it tells us that the cord will break if the tension force on this cord exceeds 75 newtons. All right, so I guess we can draw that out in another little diagram. So if I were to draw, say that this is the ball. This is the ball. If we were to draw a free body diagram, if you guys remember what those are, if we were to draw a free body diagram, we would have a tension force, a Ft force, going radially inward. Okay, it's going radially inward. So this is where we take into account that we have a tension force going radially inward. So if we were to draw a F net equation, or if we were to derive an equation from this, it would be that our centripetal force equals our tension force. Well, what is our centripetal force? Centripetal force is another way of saying it's really another way of saying our net force, because what is net force? It's nothing but mass times centripetal acceleration. Centripetal force is equal to mass times v squared over r. It's the same thing. So our FC, our centripetal force, this inwards facing force, is equal to our FT. Remember, in circular motion, and please, if you are confused where the heck this FC came from, please do look at the basics of circular motion video that I created. This centripetal force is just a force that is going radially inward in circular motion. Okay, so this FT, remember, if we refer back to our diagram, is going radially inward. So this FT force is equivalent to this centripetal force. Okay, so and we really, in all the other problems, we didn't deal with centripetal force yet. So if you are confused on what the heck centripetal force is, please do look at our first video where I do mention what centripetal force is. So centripetal force is this inward facing force, and tension force is also inward facing. So we derive the equation that FC equals FT. So what is FC? Our centripetal force, if you remember, the equation of centripetal force is mv squared over r. So mass times this and times the velocity squared over r. And that is equal to this tension force. All right, it's equal to this tension force. Now the problem tells us that Ft, if it exceeds 75 newtons, the cord will break. That means that 75 newtons is the maximum tension force that this cord can have without breaking. Okay, so we have to find its maximum speed that the ball can be moving in. Well, if you understand the relationship between tension force and velocity, you'll understand that the greater the tension force is, the greater that the ball will be moving. The greater speed the ball will be moving. The ball will be moving with the greater speed, excuse me. So we know that if our maximum tension force, and I'll do tension force in a different color, is 75 newtons, if we find v squared, that should be our maximum speed. Okay, so let's do that. What information have they given us? They've given us mass. They've given us that mass is 0.55 kilograms, and we don't really have a velocity. We're trying to find that velocity. So we'll keep v squared over on that side as a variable. Have they given us a radius? Yes, they have. Our radius is 1.3 meters. All right, so now it just comes to trying to simplify this and getting v squared by itself. So multiply both sides by 1.3 meters. 1.3 meters. And you are given 0.55 kilograms times v squared equals 75 times 1.3. So 75 newtons times 1.3 meters. And that's 97.5. Divide both sides by 0.55 kilograms. And you're given v squared to be, so this is 177. So v squared is equal to 177. I guess we can say 0.3. And now we have to take the square root of both sides so we can get velocity by itself. Take the square root of both sides so that we get our velocity to be the square root of 177.3, which is 13.3 meters per second. So this 13.3 meters per second will be the maximum speed at which the ball can be moving without the cord breaking, because we took into consideration that 75 newtons is the maximum tension force for which the cord won't break. So hopefully this free body diagram makes sense, and hopefully you understand where this Fc came from. Fc is nothing but a radially inward facing force in circular motion. So hopefully this all makes sense. This free body diagram is pretty much the key to solving the problem, and pretty much everything else is just basic algebra. Hopefully this makes sense, and thank you for watching the video.